Hi, everyone, and thanks for coming to my talk. It's about surviving continuous deployment in distributed systems, a bit of an ominous title. So before we begin, I want to show you the sponsor slide. So here are the awesome sponsors of this conference. And who is the speaker? Well, it's me. I'm Valentina. I am a lead software developer at ThoughtWorks, and there you can find some places where you can contact me if you want to give me feedback on this talk later or for any other reason. So let's start with a bit of an introduction. So what is this talk about? In short, it is about keeping production green, right? So this comes from the premise that most of us are now already practicing trunk-based development and continuous deployment, or at least it is a goal that we are trying to reach. And as we are trying to reach that, each change we make in the code base, it gets committed. And as it gets committed, it goes directly to production. And it has the potential to affect a very complex web of intricate services. As a result, it is time to think a bit more about the way that we release our software. So in this talk, basically, I would like to share my approach to how to release safely and keep production green during day-to-day story work. So who this talk is for? It is for teams who are basically beginning their journey with continuous deployment and trunk-based development. And or if you are a programmer who is stepping into a team that is already formed and it is using continuous deployment and trunk-based development. Because so sometimes this has been my experience in both as a newcomer to a team and as an experienced person onboarding new people onto existing teams. Sometimes we don't really know where to start when each change we make has immediately the potential to basically tear down all of production. So it tends to put us in a situation where we feel a bit uncomfortable and we cannot really contribute very much immediately. So a bit of a disclaimer, these practices are really not enough to step into continuous deployment. So basically, I'm going to talk about some workflow that does work in production, but if you want to be successful, I don't recommend you just step out of this room after this talk and just removing the last gate to production. I think you have to have a very strong technical foundation for that first. So for example, it's good to have a healthy relationship with the stakeholders, a robust TDD culture. You should have obviously zero downtime deployment, possibly infrastructure as code, and a lot of tests before you can really say, okay, I'm gonna do a commit and whatever I put into trunk is going to go to production. So these are some of the technical prerequisites, at least, for taking this step. And today I'm going to talk more about practices. So yes, another disclaimer. This is a guide that is very opinionated. So it has been written on my past project experience in ThoughtWorks. And obviously, I am a human being, so I have a lot of opinions about software development. And in this case, I don't really want to evangelize the way that we do software development, but rather I'd like to showcase a bit of a workflow that has worked in the past. So please keep in mind there's lots of opinions in this. Okay, now let's start with an example. So we're talking about doing continuous deployment in distributed systems. So in this talk, I'm going to use one example of a live distributed system to walk you through some type of changes that we can make to our code base. So here is our beautiful modern UI of an animal shelter management system. So we are assuming that this beautiful product is already live and there's already users using it. In this case, it is a management system for an animal shelter, and the volunteers at the animal shelter, they can log in and they can start managing the animals and manage adoptions and searching and blah, blah, blah. And we are developers on this product team. So here is an architecture. I tried to make an example that is more or less familiar to everyone. So There is, of course, a UI then that talks to an API backend and a persistence layer. And as most systems do, it also has some consumers on the backend side, and it relies on some third-party APIs. So hopefully this is some setup that can be familiar to pretty much everyone, although obviously everybody has some different configuration. Okay, so let's imagine also that this system, all of the code base is split in two main repositories, as I find that this is a very common configuration. So one would be a repo that contains the UI and all of the infrastructure that is needed to deploy this UI. And then an API repo, which contains the infrastructure to deploy it, backend code, and the persistence code. In this case, it could be database evolutions, for example. So here already we have a shift in mindset that we need to take when we introduce continuous deployment. So this shift in mindset has to do mainly with contracts. So before this, at least me, I used to think of contracts as something that is always between us and our team and our product and the outside world. So for example, I could have contract testing in between my API and a third-party system, which is the producer of something that I want to use. Or I can have a contract in between somebody who is consuming the APIs that I am publishing. So basically, this for me is an old mindset, which is contracts are always and only in between our system and outside systems. However, what I would like to propose with this talk is that we should also start thinking about contracts in between the distributed components of our system itself. So for example, not only third-party consumers consume my backend, but my UI itself is a distributed component respective to my backend that consumes its APIs. And as well, my API is a consumer of the interfaces published by the persistence layer that I have. So a better way for me to think about contracts in a distributed system is that they exist, and maybe in a more formal way, yes, between me and the outside world, but also in a less formal way between every distributed component that my team is managing. Even if I don't put a contract test between my UI and my API, doesn't mean that there is not a contract in between them. So how does this thinking about contracts affect the software development cycle? So imagine that we have our two pipelines for our two code bases. One is the UI pipeline and one is the API pipeline. And there is a gate to production here in the old world without continuous deployment. So in this world, if I have a change in which I have both a UI and an API change that rely on each other, and my front-end change depends on my back-end change, my team can basically work in any order that they want on the two changes, because at the end there will be a gate, and there is going to be one person, maybe a team member, maybe a PO, hopefully not a sysadmin with their scripts, deciding in which order to deploy things. So they will know, okay, this change relies on this, therefore I deploy in this order. So what happens when we step out of this and into continuous deployment? The gate gets removed. So we have the same situation. This change depends on this change. However, the pipelines now go directly to production. What happens? This. Because my UI will start talking differently to the backend when the backend is not ready yet. So we are stepping now into a situation where, as a development team, we need to be way, way, way more mindful of where we approach a certain change, even though we might say, okay, this user story has to be implemented by making a change in the front end, a change in the backend, and a change in the persistence. Now I have to start thinking about that much earlier than when I have written the code. I need to start thinking about that during development. So the only way to fix this is during development to release the backend code first, so work on the backend code first, and then work on the UI code, because as I commit, it's all gonna just be deployed to production, and it all needs to be perfectly retrocompatible. So I want to explore in this talk two types of changes that can affect the contract between distributed systems, and they are altering behavior and refactoring. And I want to explore more how this interdependency in the development lifecycle affects these two types of changes we want to make to our code base. So moving on, we can start with the altering behavior. So let's imagine in our animal shelter management system, our PO comes along and they ask us to introduce a reminder feature. So this is the user story that we're starting from. So as an animal shelter volunteer, I want to see which animals need feeding so that their diet can be kept on a more accurate schedule. What does it mean for our application? We have our beautiful front end again, and we would like to add maybe a menu item in the main menu to see all of my reminders, and maybe a button where I can just add a new reminder. So what is the target state of our code base? And remember that I can't just go and implement everything mindlessly. I need to now take into account everything goes to production immediately, and I can't break a live system. So the first change that, of course, will need to be made is in the UI. As we've just seen, there will be a list item, and there will be somewhere a form where I can create my reminders. Then, of course, the backend will need to have some sort of API for this. So doing an example here in Java, like maybe you have Spring and you might have a controller, and we will need to have some new endpoints, maybe one to create reminders and one to list all of the reminders for a certain user. In our first instance as well, we will need some storage for this feature, so we probably need a new little table with some reminders, with an ID, an identifier, an interval, and the user that they belong to. So this is a target state. But the question is, how can I actually get my code base in its target state before, without breaking production, basically? So as we've seen before, I would need to deploy the changes in the reverse order of producer and consumers. So starting with the innermost producers first, then stepping out to who consumes them, and then stepping out to who consumes them. So in our case, we would need to start from the persistence because the backend cannot work without the table. And then we can move on to the backend, and then we can move on again to the UI. However, is this optimal for development? Maybe many people would argue actually it is not. So one thing that we talk a lot about at ThoughtWorks is the outside-in principle, which kind of states exactly the opposite that you should do. So the outside-in principle basically tells us that we actually want to implement features starting from the outside layer of a system and then move in the inside layers. Why do we want to do that? Because there are many benefits. So one of the main ones is that you get an early validation of the business requirements. So you start with the most visible part of your system to the users. And also, as you go and you code into the code base, every layer that you touch, its code is driven by its client. So you know, for example, that you're not writing unnecessary abstractions or unnecessary parameters, and you have basically less risk of rework. Also, fun fact, it works really well if you use the mockist or London School of TDD, because basically as you go, you mock just every layer below you. And also it allows us to respect sort of the principles of the consumer-driven contracts. So basically, I would like the contract of my API to be driven by my UI, and same for the persistence. So this is how we would rather work. How can we achieve that? Because according to this principle, actually, the order in which it is ideal to work, it is exactly the opposite of the one that I need in order to not break production at any step. So we achieve this with feature toggles. So feature toggles, or some other people call them feature flags. Martin Fowler calls them feature flags. They are techniques to decouple the deployment time of your code to the release time of your code. It's basically a flag that allows you to ship an alternative code path. And the code at the runtime will decide in which branch of logic to execute based on the state of the toggle. This state, it has to be stored outside of your application code so that it can be completely independent from the deployment time. in other words, all of this to say it is an if statement, pure and simple. So when you have a feature toggle somewhere in your code, you will have a statement like this. So why do we want to use them in this case? Because they allow us to decouple the order of changes that we need to not break production from the order of changes in which we want to work, because it allows us to hide half-baked code that doesn't yet work from the users, even if it is live. Some other benefits as well of feature toggles, maybe most of you use them already, but in case you already do, maybe you haven't seen that you can use really fancy sometimes toggle libraries, and they allow you to do really cool things. Like if you have some libraries like toggles with a Z, you can enable them even by user or by session or by request. And this way you can maybe give this power to your QAs or your POs, and they can perform QA directly in production of the feature in production, which I find really cool. And then in other cases, you can also configure the toggles per percentage. This allows, for example, the business to do an A/B test of a feature versus no feature, and that way you can get some data behind your product decisions as well. So just in case you haven't thought about using feature toggles this way, you can also do that. So here is how we would go on and implement our feature under a feature toggle, so going with the outside-in principle. First, we would have the front end exactly as we did before, but in addition to what the target state was, we also need some boilerplate code here. Here we would read some feature toggle state, and if the feature toggle, in this case I represented it with this constant, is enabled, then we would not hide these new things we have. If the toggle is disabled, we can just immediately hide them from the users. So it doesn't matter that we are doing this release first, because even if it's broken and this API I'm calling, it doesn't work yet, the users cannot see that in any way. Where would I store this state that I showed you in the past slide? I could store it in S3, in SSM, or some configuration files. Some people even store it in the database, although I'm not such a fan of that. But yeah, anywhere that is external to your application code. So then after the front-end release, I can now safely make my back-end release. I can write my 2 new endpoints. It doesn't matter that my persistence is not there yet. So yes, I'm writing to an empty database, a non-existent table. This would throw 500, but it doesn't matter because the users can't access it. And then finally, I can go on and write my table in the outside-in order. So that's it. That's our first section over. So the summary of this is, if you're implementing a new feature and you want to respect the outside-in principles, you can use feature toggles to hide half-baked implementation from the users and not expose broken functionality. OK, so for our second section, which is refactoring live features. Let's again start with an example, and we're going to have an example refactoring. In this example, we are going to change the way that a currency is represented in this system. So imagine that you're a developer, and as it happens, sometimes you go on your favorite blog or Hacker News, and you find this fascinating article that tells you, oh, actually, computers are never good at representing money with floats because they round up in silly ways, and so it's not a great idea to have your calculations for money in floats. And then you remember, oh no, there is a feature of our animal shelter management system which you suspect might have this issue. So the feature we're going to talk about is adding expenses for the animals. So a volunteer buys something and then wants to expense it to be reimbursed. So you go in and you look at the feature and you see that there is this form where the user has to enter the amount of the expense. And you remember, oh no, let me open the code. And how does the system look like now? And you see this. There is a parse float in our system. That is a problem. So we would like to refactor it. So we go in the backend and see exactly how deep the problem is. We find that actually it is all over our backend as well. So our amounts are all represented in floats everywhere, which is really, really bad. We see that, however, the persistence is saved because actually in our database it is represented as cents, and the amount gets rounded to the nearest 100. Sorry, not rounded. It gets multiplied by 100, and in the database it is actually stored as an integer. So how we would like to store it. So as a programmer, I scope the problem to just the contract between my UI and my API. Okay, so how do we fix this big issue with our system before anybody notices, hopefully? What is the target state I would like? Well, I would like here in my front end already to begin having the amount in cents. So, for example, 2 euros would be 200 cents. And I would like to do so with a parse int instead of a parse float. And of course, the target state of my backend would be that there's integers everywhere, all the way through to the persistence. But how do I get there without breaking production again? Because this system is live, so I can't change things and step in from wherever I feel that the type should be moved to be integers. So let's explore some order that we could use. So if we do the backend first and the API second, I'm going to be in trouble because the UI is going to start sending integers while the backend is still receiving floats in its API. So this will cause a big error for my user. Other scenario is not better either, because if I change the backend first, of course, keeps receiving floats and this is sending integers. So in whichever order I approach this, I'm going to be screwed because I have to break at some point the functionality. Or do I? There's a pattern that is called expand and contract that I can use to solve this problem. It's also called parallel change. And it is a technique that I can use to basically perform this operation in a safe way and change the shape of the contract. It consists of 3 phases. The first is called expand. So basically, I have an interface like my backend API, and I can create a parallel one that is using the flow that I would like to use, and that is not being called yet by any client. Then I can perform a migration phase in which all of the clients that used to use the old interface, they can now switch to the new one. And after that, I can safely remove the old interface that I don't want to use anymore. So this flow has to happen inside out because, of course, the interfaces are the ones exposed by the producer systems, so the innermost systems. So it means, in our case, we would need to go from the API part of the application in order to the UI. Of course, you can use also feature toggles as a workaround to this. However, they don't have as many benefits as with changing behavior. So feature toggles add a lot of overhead. And if they're not really used to hide functionality from users, this overhead can be a little bit too much. So here as well, we are refactoring. We're not having to explore APIs. So really, there's not even many benefits to working outside in either. So we can safely go from the inside to the outside, and it tends to be better. Unless, of course, you're doing a huge refactoring and then you prefer a feature toggle. But we can talk about that in the Q&A maybe. So how would I do the change with these phases? First, I will start with the expand phase, where I want my backend to speak the integer language and persist this amount in cents. So what do I need to do in order to achieve this? I need to expand my interface. So the interface to my API needs to receive both types of payload for a while. Decide, are you trying to use the new interface? Okay, then I will just convert what you sent me to what I want. If not, if you're using the new interface, I will just use what you sent me. Obviously, you could also make a separate endpoint for this, but I wanted to show you a less kind of common case for expand and contract. Okay, so then we would jump to the migrate phase, where the frontend can be safely changed to send integers, and it will do this call to the backend, and magically it will work because we've already implemented the second flow for our application. Then finally, I can move on to my contract phase and clean up all of that terrible boilerplate code that I had to put in place for having both flows up. and I can just receive my payload as I want it and persist it easily. And this is pretty much it. So when we are refactoring existing features, and this impacts the contract between distributed components of our systems, it's better to approach from the inside out of our system and then apply, expand, and contract. So I wanted to make a brief mention to data and deltas or data loss, because things are rarely that simple. So you might have noticed that I very conveniently left out of my previous example the database layer. And this is for a reason, because there's a whole section dedicated to it. So what if our persistence layer also presented this problem? If our persistence layer also had the decimal amount here, I would be in a slightly more tricky situation. This would be the current state of my repository. So instead of doing a pre-conversion to cents for the amount, it would just immediately store it as a decimal. And we can imagine that our API and our UI are in the same state with flows as they were before. So now the change is permeating through our entire system. What would be the target state of our persistence? Of course, if we had to fix it, what I naively would do would be to say, OK, let's change the table expenses, correct the type of this column that I want to be actually in integers, and do this conversion by multiplying the existing amounts to 100 and converting them to integers. So this naively is how I could approach doing this change on the database. I would migrate the historical data, and then the backend at some point would start writing the correct type. And this is how it would be represented afterwards. OK, so this is how this target state would look like after my changes. So I would need to then do what I was doing before, which is convert the amount to 100. However, again, how do we get there without breaking production? So again, naively, sometimes, because our persistence code is always stored together with the backend code, or in most cases, I saw that it is, a lot of people do one change in the entire repository and just deploy everything together. However, if you're not careful, this actually can lead to pretty serious data loss. So even though your database and your backend code are in the same repo, and maybe they're even being deployed by the same pipeline, it doesn't mean that they are going to be deployed at the same time, because they are actually independently deployable units. So what is going to happen is that imagine your database evolutions get applied first before your deployment. The old instances of your application will actually keep writing in the old format, even if you send the code up all together. And for a brief period of time, this is going to happen. So you're going to have your table, and the historical data is going to be migrated right away, but the application is keeping writing in the old format. And only after the application catches up to, the data will start being correct. But in this brief period, your users are going to get errors, and your data is going to be lost. So yeah, the lesson here is do isolate the changes that belong to different components. So even if you have in the same repo stuff that is deployed more or less at the same time, do make the releases separately. So this was not a good idea. Then can we apply, expand, and contract to this as we did before? If I had to apply, expand, and contract here, the phases that I would have would be maybe to create a new column. So I'm expanding my persistence interface by creating amount in cents column, and the backend would still write to the column amount. Then I would need to migrate my backend to write to the new column. And finally, I could remove the old column that I don't want to use anymore. However, here we also run in the same problem, because if we apply expand and contract like this, between the expand and contract phase, we're going to have also a data loss. Why is that? Because after we do the expansion, we would have the new column with maybe the existing historical data converted to int. But until my backend is actually deployed to migrate to the new column, actually, the data is going to be lost in that brief moment. And only after you've caught up with the backend, again, is going to be persisted right. So how can we avoid data loss? Like, is there any way to do that safely if we need to refactor our persistence layer? Refactoring databases book suggests a database trigger for this, but as we are in 2021, I don't feel like in good consciousness I can recommend using database triggers to you. So for example, I am going to propose an alternative approach here because I really don't like this. So this, I call it preemptive double write. So the way that I avoid data loss in these situations is to use expand and contract pattern. But even before that, I would like to add a step in which my backend preemptively tries to write already to the new column, and it tolerates a failure in this case, so that when I do finally add the new column, it's going to start writing immediately. And this is an alternative way to synchronizing the two columns with a trigger. So how would I implement this change with the preemptive double write? This would be my first release on the backend, where I would basically have here a try block that says, OK, persist into the old, but also in the new one, and tolerate a failure. So it's fine. This column does not exist yet. Therefore, it's fine if it fails, because I know I have the database in this intermediate state. And then finally, we can move on to our expand and contract. So we have then our expand phase where we can add the amount in cents. And as soon as this release is deployed and the database evolution runs, actually my backend is already writing at this point to this column, and the failures won't happen anymore. So here I am not losing any data, because as soon as the code is there, it starts writing to both. And here would be my code in the backend changed in the migrate phase. So then it would write into the new table amount cents with the correct format that I want. And finally, I can move on to my contract and clean up my persistence layer and drop the old column amount. So now, between at least the persistence and backend, we are in exactly the same situation that we were before. Now, if I wanted to complete my refactoring, I could do the things I did in the second section, which is then do a normal expand and contract between the front end and the persistence. And then I would have gone through all of my system to correct this defect. And just one thing to point out is that all of this would be 7 releases in total. So if summing the releases for the persistence to backend and backend to front end, that is a lot of releases if you compare it to a system without CD, where you would just have 3 basically, because you can deploy whenever you want. So yeah, this is the overhead that you incur when you have continuous deployment. And of course, it is a normal thing, but also we need to be mindful that it is not simple to have continuous deployment. So here's a summary of this section. So do be aware of all data and deltas in your writing, because you might incur in very serious data loss. So if your application cannot afford it, then you have to go through some more hoops in order to ensure that you are writing all of your data and you're not losing any transactions. Okay, so now we've seen all of these patterns and techniques for handling our changes safely. And I would like to just close with how do we put them all together when we receive a new user story. So we saw as a summary of our section that we would like to always approach new features if possible, so by adding feature toggles and go from the outside to the inside. And then if we have instead a refactoring to make, we would like to do the opposite, apply expand and contract, and go from the inside towards the UI. But the world is actually rarely that simple. So sometimes we get a task in our backlog that actually has a little bit of refactoring in it and a little bit of new features in it. So in those mixed cases, it might be a little bit tricky to arrive to a conclusion on which approach actually is the right one. So I want to explain this with the last example, which is a feature addition that would also require some heavy refactoring of the system, which could be to have expenses, but with a type. So not only food expenses for my animals, I want to support my volunteers in adding, for example, stationery expenses for the office and other things that they might want to buy. So here, instead of the form that I had before, I would like to enable them to add a type next to the amount. So which approach is this? Because we do need to change radically the shape of this type throughout our code base, but at the same time, we want to add something new. So would we go inside out or outside in? Here, I would like to talk a bit about pre-refactoring or preparatory refactoring, which is a technique that Martin Fowler talks a bit about in his workflows for refactoring talk. And he says, whenever you get a change that has a mix of both things, the best thing to do sometimes is to pre-refactor the system without introducing the feature, but refactor it so that it is in a shape where adding the feature is incredibly trivial. So it is maybe a one-line change. So pre-abstract and then do just the bare minimum to introduce the new feature. So how would we approach this in this way? We would do a refactoring first, and we know how to do a refactoring because we go from the inside out with the expand and contract, and then we could add the feature again outside in. So this is the story plan that I would write to myself with the sticky notes on my table if I had this user story. So I would split it in these two phases. So first, do a preparatory refactoring where I add a type to the expenses in the system. So it's not just a number. It is now a complex type that can also have a type of expense next to it. And maybe the default could be it's always food for now. Then on the second phase, I can start adding my functionality, and all I need to do is a one-line change. So this is it. The summary of this is I always encourage you to take these techniques, and the moment that you receive a new task or a user story, if you're doing continuous deployment, make a plan of how you're going to release it. So don't just kind of go into the code and start thinking, oh yeah, I need to change this over here and this over there. I'm just gonna push it to master and see what happens. So make a plan for yourself of which releases are gonna be needed and in which order, so that you don't introduce defects that are visible to your users. And that is how I do it. So that's pretty much it. This is a summary of everything that we've seen now. So basically, the first thing we saw is it's good to use feature toggles for adding behavior and approach from the outside in. Expand and contrast for refactoring. We should be aware of data loss in our system and maybe preemptively double write to ensure expand and contrast safely, and always tie it together in a story plan before you begin implementing whatever it is you need to implement. And that's it. So thank you. This is, again, my email and my Twitter handle if you want to reach me somehow. And here you have actually some resources that you can read if you're interested in going a bit deeper in some of these practices. They have been written about plenty before, obviously. So yeah, thanks. I think, do we have time for Q&A? Yeah, okay, so is there any questions? Okay, sorry. So the question was more or less what is the added overhead in time, for example, by having 7 releases instead of 3, because you've introduced continuous deployment. I hope I summarized it okay, yes. Well, it is actually, so it's considerable overhead, I would say, but it's not that bad in my experience. Obviously, so my example was based on the assumption that you have one team managing front end, back end, and persistence. So hopefully you don't need to ask another team to make a change in front end and a change in back end. If you do, maybe continuous deployment shouldn't be your priority. Maybe you should be having more cross-functional teams. But even with one team managing all of this and without communication overhead, I do think it's not so much an overhead in time, but an overhead in cognitive load. Because at any given time, you have to be aware of, okay, I am releasing this, but should it actually be before that? And will this work together with this change? Is everything retrocompatible? And obviously, if you have a gate to production, you have time to fix your mistakes if you notice that it's not retrocompatible. But if you don't, then you're almost in emergency mode, right? Because you need to go and pause the pipeline, make sure that it doesn't reach production, or it might be too late if your pipeline is really fast. Yeah, I hope that answers the question. No? Okay, good. Then we can all get some food and coffee.